How do we know the value of any physical quantity? By measuring it. If you want to find, say, the diameter of a quarter, you can take a metric ruler, lay it across the quarter, and find that the diameter is about 24 millimeters. But how precise is this number? Can we be sure that the quarter isn't 24.1 millimeters or 23.9 millimeters in diameter? Clearly, the precision of our measurement will depend on the device that we use for the measurement. Consider the example of measuring a quarter. If we use a ruler that only has centimeter markings, we can only say with certainty that the coin is bigger than 2 centimeters and smaller than 3 centimeters. We can, of course, try to estimate how close to 2 or 3 centimeters the diameter of the coin is. When one edge of the coin is aligned with 0 on the ruler, the other edge is roughly halfway between 2 and 3. So we could guess 2.5 centimeters or 25 millimeters. If we looked really carefully, we might have seen that the edge of the coin is not quite in the middle between 2 and 3, but a little closer to 2. We could then guess that the diameter is actually perhaps 2.4 centimeters, not 2.5. That is really the best guess that we could make. Now assume that we have a metric ruler with markings for both centimeters and millimeters, as in the picture. If we lay this ruler over the quarter with one edge of the coin aligned with 0 on the ruler, the other edge is going to be almost at the 2.4 centimeter marking. So we can say that the diameter is about 2.4 centimeters with much more certainty. However, when we look closely, we notice that the edge of our particular coin is not quite at 2.4 centimeters, although it is close. The edge of our coin is actually between 2.4 and 2.5 centimeter markings, although it is much closer to 2.4 centimeters, perhaps 4/5 of the way there. We can then guess that the size of the coin is probably about 2.42 centimeters. You can see what is happening here. Because we had a finer scale on our ruler, we were able to measure the size of a coin more accurately. In this case, for a scale that was 10 times finer, we could find one more additional digit for the diameter of the coin with certainty. That is, we could say that the diameter was between 2.4 and 2.5 centimeters, not just between 2 and 3 centimeters. We were also able to guess an additional digit. That is, we said that the diameter of the coin is about 2.42 centimeters, not just about 2.4 centimeters. If we used a micrometer with markings for 1/10 of a millimeter on its scale, we could be able to measure the diameter of the quarter yet more precisely. The actual standard size for a US quarter is 2.43 centimeters, although this value might vary slightly, perhaps due to wear. Of course, such considerations don't only apply to rulers. For instance, a pharmacist's scales is much more precise than a bathroom scales. The former allows for milligram or even microgram precision, whereas the latter only allows measuring masses to say the nearest 100 grams. Generally, for any measurement instrument that has a continuous scale, such instruments are called analog. We can with certainty say that the value of the quantity that we are measuring falls between the finest markings on the scale, and we can estimate where between these markings it falls. Therefore, the last certain digit in our measured value has the same order of magnitude as the finest markings on the scale of our instrument, and the digit that is one order of magnitude smaller can be estimated. Unlike analog instruments, digital instruments don't have a continuous scale. Instead, you can read the measured value off a screen, with the instrument returning a certain number of digits. You can see an analog bathroom scale on the left and a digital bathroom scale on the right. For a digital instrument, you should assume that all digits it returns, but the last are certain. The last digit is estimated. You may have noticed that the last digit on a digital scale, for instance, will often fluctuate while you are standing on it. In science, values of physical quantities are reported to such precision that all digits but the last one are certain, and the last digit is estimated.